Hi, hello, and welcome. So today I will be discussing two very special topics. So let's start with the first topic, API system call OS relationship. Now to know the relationship between these three, we need to know their definitions individually. So first up is API. API means Application Program Interface. It's basically the application itself. It is a set of routines, protocols, and tools for building software applications. The next is system call. System call is programming interface to services provided by the OS. It is a request in Unix-like operating system made via a software interrupt by an active process for a service performed by the kernel. So this is basically the code to the application. The next is the operating system, which is the OS, which provides an environment for execution of programs and services to programs and users. So now that we know the definitions of these two, we can now move on to their relationship. So here, the API is the user application. The user application, let's say the user application sends out the line of code, open, to the system call interface. Now the system call interface is different from the system call. Let's say that the system call is a word and the system call interface is a dictionary. So system call is a part of the system call interface, and open can be considered as a system call. So the user application, the API, will send out a line of code which the system call interface will then process in here, and then look for a counterpart in the OS implementation. And once the implementation of open system call is found, it will be reprocessed, and then the result of the code will then be returned back to the system call interface. Then the system call interface will return it back to the user application. So that's basically the relationship between these three. But a more specific explanation would be this, the standard C library. Now, as you can see, this this code, this is the API, and the standard C library is the system call interface, and the right system call is the OS. So here, the line of code which will be sent out is printf greetings. It will be sent into the standard C library to be translated into the OS programming language. So printf is equivalent to write in the OS programming language. Write will be processed inside the OS, and the result will be sent back into the standard C library, which will then be sent back to the API. Then the API will display greetings. So that's the very first special topic I'll be discussing today. And the next one is microkernel system structure. So what is a microkernel? A microkernel is the near minimum amount of software that can provide the mechanisms needed to implement an operating system. So here's the microkernel system structure. This is the user mode. These are the APIs, if you still remember what an API is. And this blue box is the OS, and these are the services of the OS. And these lines are the microkernels that connect all these things to the hardware and to the API and the OS. So the microkernel, going back to this definition, is the near minimum amount of software that can provide the mechanisms needed to implement an operating system. So imagine microkernel as a grain of sand which can do a minimum amount of programming on the system. So here, These are the grain of sand that I'm talking about. So the OS has been split up into different services. Now these services, to make processing more efficient, the let's say an application program, an API, wants to only use inter-process communication. You can directly connect it using microkernel without touching memory management or CPU scheduling. So it will become more efficient and more direct. And let's say application program and file system want to use inter-process communication. So they can both use it with microkernels without affecting each other's performance. So yes. So microkernel also connects to the hardware, and basically it makes the processing speeds more efficient and more reliable. So that's all for my discussion and two special topics. And thank you very much for listening. If you liked the video, give me a like and comment below. And thank you.